Welcome to The Explainer. Today, we're unpacking a massive historical paradigm shift, the story behind one of the absolute, unbreakable rules of our universe. We completely take it for granted today, but the discovery we're about to explore literally flipped the scientific world upside down. So just think about this for a second. What connects a falling apple, the majestic orbit of the planets, a roaring fire, the massive turbines of a power plant, and the smartphone you're probably holding right now? I mean, on the surface, they seem completely unrelated, right? But underneath it all, they're governed by a single, beautiful, unifying thread. And that thread is this: energy never disappears. It doesn't just vanish into thin air, and it certainly doesn't pop into existence out of nowhere. It only ever transforms from one form into another. Now, sure, that sounds like basic middle school science to us today, but there was a time when this was a wildly radical, highly controversial idea. It actually took two brilliant, totally unlikely heroes, a young German ship's doctor named Julius Robert von Meyer, and a meticulous English brewer named James Prescott Joule, to finally prove it to the world. Part 1. The caloric mistake. To really appreciate what our heroes accomplished, we kind of have to understand the massive obstacle they were up against. Because before the mid-1800s, top scientists honestly believed that heat was a physical substance. Yeah, an invisible, weightless fluid called caloric that literally poured from hot objects into cold ones. Basically, if you heated up a pot of water, you were supposedly filling it up with this caloric fluid. But there was a glaring anomaly that this caloric theory just couldn't explain. Think about it. If heat is just a fluid moving around, why does rubbing two things together create heat endlessly? Like, rub your hands together on a cold day. You can keep doing it and keep generating heat. So where is all this endless fluid coming from? Does it just magically appear out of thin air? The math just didn't add up. Part 2. A doctor's tropical clue. So the first crack in this flawed theory came from a really unexpected place: a young doctor named Julius Robert von Meyer. In the 1840s, he was working as a ship's doctor, sailing on a Dutch vessel headed for the tropics. While performing a routine medical procedure of the time, bloodletting, he noticed something absolutely astonishing. Back in Europe, the venous blood of his patients was typically this dark, purplish-red color. But here, in the sweltering heat of the tropics, the venous blood was incredibly bright red, almost like arterial blood. He realized this bright red blood was rich in unspent oxygen. But why? Well, because in that hot tropical climate, the human body just didn't have to work as hard or burn as much oxygen to maintain its internal temperature. The body literally spent less energy heating itself. That was the aha moment. Meyer made this profound biological deduction. Animal heat was a chemical process, and heat itself was directly linked to internal energy and work. Heat wasn't some magical fluid at all. It was a form of energy. Part 3. The brewer's ingenious experiment. Now, while Meyer was observing blood, James Prescott Joule was back in England tackling the exact same problem, just from a totally different angle. Joule actually grew up working in his family's brewery. And because he spent his whole life measuring temperatures and optimizing industrial brewing processes, he had this deep appreciation for highly precise physical experiments. So he set up a lab, began publishing groundbreaking papers, and became absolutely determined to measure the exact mathematical relationship between mechanical work and heat. He created this brilliant apparatus to test his theories. He rigged up heavy lead weights to a pulley system. As those weights fell to the ground, they pulled strings that rapidly spun brass paddle wheels inside an insulated container of water. The mechanical friction of the paddles churning that water caused its temperature to rise. He meticulously measured the exact distance the weights fell and the exact temperature increase of the water. Through intense repetition and just incredible precision, Joule established the exact mechanical equivalent of heat. He proved that to get a specific amount of heat, what we call 1 calorie, you need a precisely defined amount of mechanical work, 4.186 joules to be exact. By putting a hard number on this, Joule drove the final nail into the coffin of the caloric theory. He proved experimentally that work and heat are perfectly, entirely interchangeable. Part 4. The first law of thermodynamics. The biological insights of the doctor, combined with the mechanical precision of the brewer, essentially birthed a brand new era of physics. You'll often see their first law written mathematically, like this: delta U equals Q minus W. Now, in plain terms, that just means the change in the internal energy of a system is equal to the heat added to it minus the work done by it. Ultimately, the total energy of an isolated system is always absolutely constant. You literally cannot make new energy, and you cannot destroy the energy you already have. Okay, so why does this matter? Well, because this abstract math dictates literally everything you do in your daily life. A light bulb doesn't create light. It just transforms electrical energy into light and heat. Your car. It transforms the chemical energy of fuel into mechanical motion. A hydroelectric dam turns the potential energy of falling water into kinetic energy and then into electricity. And what about your own body? You're basically a biological engine transforming the chemical energy of the food you eat into thermal heat and mechanical movement. Every single action around us is just a grand recycling of existing energy. Part 5. The universe's ultimate rule. See, this law governs absolutely everything in existence. It dictates the massive thermal engines of Earth's climate and weather systems. It governs the burning nuclear furnaces of distant stars and the kinetic motion of the planets. It even holds true all the way down at the microscopic level in quantum physics. Think about it. When a massive star goes supernova and explodes, its immense energy doesn't just vanish into the void. It simply changes form, scattering into light, heat, radiation, and kinetic force across the galaxy. And this is exactly why the work of Mayer and Joule was such a massive paradigm shift. They destroyed the old caloric theory and laid the foundation for modern thermodynamics. Without their understanding of how heat and work interact, we never would have been able to invent the internal combustion engine, modern refrigerators, or the power plants that keep our cities running. Our entire modern technological world relies entirely on this one single concept. But beyond just engineering and power plants, there's a profound philosophical beauty to the scientific law, especially when we tie it back to biology and nature. I absolutely love this quote by Julius Robert von Meyer from 1867. He wrote, "Nature has put itself the problem how to catch in flight light streaming to the earth, and to store the most elusive of all forces in a rigid form." He was talking about photosynthesis, how plants capture solar energy and lock it into chemical bonds. It perfectly highlights this incredibly beautiful closed loop of eternal harmony in our universe, where absolutely nothing disappears without a trace. Light becomes chemistry, chemistry becomes motion, motion becomes heat. So, I want to leave you with a thought to chew on. Mayer looked at blood, Joule heated up some water, and together they managed to unlock the eternal machinery of existence. If every single bit of energy pulsing through your body right now is eternal and is literally as old as the universe itself, what will it transform into next? If you're fascinated by the history of great discoveries, make sure to subscribe to Universe Code. This is where physics comes alive through stories. Catch you next time.